Howdy folks, we're going to get right into some 3D toolpaths here in Fusion 360 for Project Lead the Way's Computer Integrated Manufacturing class. So we've got our ski hill part here, which we gave to you so you don't have to model this. And if you look at this, there's no flat surfaces on the bottom where the part is actually going to be machined. So our two-dimensional toolpaths, which is everything over here in this tab, everything over here, it relies on the bottom surface being flat. Three-dimensional toolpaths is what you're going to need for this ski hill and for the next model too, which is a complex surface. So I'm going to jump right in here and we'll do a setup quickly. And I'll get right into it with the 3D. I like to use adaptive clearing, and what this strategy is going to do is it's going to quickly remove a bunch of material. Speeds and feeds for simulation is okay. Geometry, you don't need to actually select anything. You could select these guys here. You could choose faces, and then we'll select these faces. Our action is going to be to machine the surface. I'll choose OK. Essentially what this is going to do is it's going to look at the part, figure out what it thinks you want to machine, and then figure out the most efficient way based on tool geometry and tool diameter using this right here called optimal load. So if you don't have optimal load selected or adaptive selected, what you're going to get is you're going to get what you see on the bottom left there, where you've got a large amount of your tool engaged in your material. Well, that is okay if you're not cutting very deep. That's okay if you're not cutting very fast. But for this, we want to remove this extra material as quick as we can. And we want to not damage our tools when we do it. So we're going to use this, and I definitely want to check off stock to leave. I want to not cut all the way down to my final surface because this is a roughing operation. We are not going to be done after this. We have to go back and fix it or finish it. So I'm just going to choose OK and let the machine chug its way through this, and you can see its toolpath there. Looks okay. Fusion does a good job of giving you a simulated look of it, what it's going to look like after it machines all of this. So again, I got all my linking moves are in yellow, or my rapids are in yellow rather. My greens are my linking, and my blue is my cutting move. So as you kind of take a look at this and look through this, you see we're getting most of the material off, but we're leaving some stair steps, which is not our smooth finished ski hill. To check our machining time, we'll right click and choose machining time, and we can see this takes 4 minutes and 5 seconds to go through based on the speeds and feeds that I didn't adjust. So adjust accordingly with your machine and material and tool selection. Now that we've got most of the material removed, it's time to go back and actually smooth this out. So I'm going to come in here and I'm going to choose a parallel toolpath. Anytime you're doing a three-dimensional tool finishing operation, you want to use a rounded tool. So I'm going to switch over to my 3/8 ball end mill. Geometry I'm going to leave alone again. Heights I'm going to leave alone. Passes, you got to play with this step over here. Okay. The default for Fusion is probably going to be half of the tool diameter. So if I do that and I type in 0.1875 for half of my tool diameter, you can see that it's going to do like cutting the grass. It's going to go down, up the hill, over, down the hill, up the hill, over, down the hill, which is okay. However, if you zoom in on this and look at this, you're actually going to leave these cusps here. You're going to leave these ridges. If that's what you want, then you're good. Unfortunately, that's not what we want. We want to try to smooth this out more. So the way we're going to do that is by adjusting our toolpath to make these lines closer together, these step over lines closer together. So I'll just come over here, double click to edit my toolpath, come over to my passes, and I'll change that to say 20 thousandths. Now you can see it's going to go up the hill, down the hill a lot more time, which is going to give us a smoother surface. So if I simulate and run through this, I'm going to try to speed this up a little bit. If I simulate this, you can see it's not cutting a whole lot of material at once. It's making a bunch of passes up the hill and down the hill, but its step over is really, really small, 20 thousandths of an inch. So it's going to take a little bit longer, but your surface finish is going to be a whole lot smoother. There's no way around this. If you want a smooth surface finish, you have to spend the time. Alright, I just want to show you one other thing in this video here. Let's say I didn't want to go up the hill, down the hill. What if I wanted to go across the hill? Pass direction. So instead of 0, if I change that to 90, it will recompute my toolpath and go across the hill. Same step over, 20 thousandths. It will just go across the hill. And now it's taking its time here. Oh, there we go. Oh no, this isn't good. Alright, we're back after the freezing. So you can see it's, instead of going up the hill, down the hill, it's going across the hill. And you can play with these settings, change that angle to 45 or 30 or 10 or whatever you want. The name of the game here with the 3D is play with the tools, play with the different operations that you have, play with the settings in there. I generally only mess with step over or pass direction to sort of get what you want. So that takes us through the ski hill.